Do you know how the white sugar we use every day in tea, sweets, or cooking is made from sugarcane? After sugarcane is cut from the field, work must begin very quickly, otherwise its sweet juice can spoil. Then step by step, the sugarcane is cleaned, juice is extracted, the juice is concentrated, crystals are formed, dried, and packaged. Today we will see in a very simple way how sugarcane from the field travels through a factory and reaches the sugar packet in your kitchen. Let us begin. After sugarcane is cut from the field and brought in, a long and extremely complex process begins, at the end of which the familiar white granular sugar arrives in our kitchen. As a robotic harvester machine enters the field, the powerful base cutter blades attached to its front section cut the base of the sugarcane precisely at a level very close to the ground. At exactly the same moment, the topper blade located on the upper part of the machine cuts and separates the leafy top portion of the sugarcane. Because the sucrose content in this upper part of the sugarcane is extremely low and it is completely unsuitable for processing. The cut cane pieces then immediately enter inside the machine and a powerful chopper mechanism cuts them into small pieces of 20 to 30 centimeters in length. After that, a fast-moving elevator belt lifts these pieces upward and drops them into a large trolley or truck moving parallel to the side of the machine. High-capacity cameras and various types of sensors installed inside the machine monitor the quality of the sugarcane at every moment. And if any stone, large clod of soil, or any other foreign object gets mixed with the sugarcane, the machine automatically detects it and separates it. An advanced robotic harvester machine is capable of cutting and preliminarily processing up to 100 tons of sugarcane per hour, which is much faster, more accurate, and more cost-effective compared to work done by human hands. Trucks loaded with sugarcane from the field set off toward the sugar factory. And through RFID tags attached to each truck, the factory's central computer system continuously monitors the location of the trucks and their estimated time of arrival. This automated truck management system determines the arrival time of each truck to avoid the traffic congestion that can occur when many trucks arrive at the factory yard at the same time. After arriving at the factory, the truck first stops at an automated weighing station where the total weight of the truck loaded with sugarcane is measured, and later the net actual weight of the sugarcane is determined by subtracting the weight of the empty truck. At the same time, samples of the sugarcane are collected with the help of automated instruments, and the sucrose content and Brix level in them are measured, which plays an important role both in determining the farmer's payment and in the factory's daily production planning. After weighing, the trucks move to the unloading station, where, with the help of a hydraulic tipper system, the rear portion of the truck slowly rises and all the sugarcane inside falls into a huge receiving pit. From the receiving pit, sugarcane begins moving to the factory's processing area through a large conveyor belt. While passing over this conveyor belt, first a row of powerful magnets pulls out and separates any metallic objects accidentally mixed with the sugarcane, such as pieces of broken machinery, iron wire, or nails. This magnetic cleaning process is extremely important because metallic objects can later cause serious damage to the mill rollers or other machinery. After that, a high-pressure water spray system cleans the mud, dust, and other dirt from the field that is stuck to the sugarcane. The cleaned sugarcane then enters the first processing machine of the factory, the knife machine. In the knife machine, many sharp knives are attached to a large rotating drum, and spinning at high speed, they finely cut the sugarcane into small chip-like pieces. This cutting process breaks the hard outer covering of the sugarcane and exposes the inner cells, which makes the subsequent juice extraction work much more effective. After the knife machine, the sugarcane pieces go to the shredder machine, where more powerful knives and heavy hammer-like components combine to tear the sugarcane pieces more finely and turn them into a fibrous soft mass. In this condition, the cells of the sugarcane are completely broken, and the sweet juice inside becomes completely ready to come out. The shredded sugarcane then enters a long series of roller mills. Generally, a factory has 4 to 7 roller mills arranged one after another in a line. And in each roller mill, massive and extremely heavy metal rollers crush the sugarcane fiber under tremendous pressure to extract the juice from inside. In each mill, clean water or weak juice coming from the previous mill is sprayed. This method is called maceration, and it is an extremely effective technique for extracting the remaining juice trapped in the sugarcane fiber. After passing through the entire series of mills, it becomes possible to extract approximately 95 to 97% of the sucrose from the sugarcane. The dry and light fiber that remains after crushing is called bagasse, and this bagasse is burned as fuel in the factory's boilers to produce steam and electricity, which is capable of meeting a large portion of the factory's own energy needs. And this is a wonderful example of using energy in an environmentally friendly way. The raw sugarcane juice that comes out from the mill appears dark green or brown in color. And besides sugar, it contains large amounts of impurities, fine soil particles, organic matter, proteins, wax, and various chemical compounds. Since this juice is not directly usable, a long process of cleaning it begins. In the first step, the raw juice is taken to a large mixing tank, and a precise amount of lime or calcium hydroxide is mixed into it. As a result of adding lime, the pH level of the juice rises and becomes alkaline, and various impurities, organic compounds, and protein-like substances in the juice coagulate through chemical reactions and become heavy, which makes it possible to separate them easily afterward. At the same time, the juice is heated to a temperature of 70 to 105 degrees Celsius so that the bacteria and enzymes in the juice are destroyed and inversion of sugar or the reversal process can be prevented. Because inversion causes sucrose to break down into glucose and fructose, which reduces sugar production.
In some advanced factories, a carbonation method is used, where carbon dioxide gas is passed through lime-treated juice using a special machine. This gas reacts with the calcium from the lime and forms fine white crystals of calcium carbonate. These crystals, like a sponge, trap the various impurities, colored substances, and colloidal particles floating in the juice and make them heavy, which can then be easily separated as sediment. The purity of the juice increases significantly through this method. Alongside this, some factories also apply a sulfitation method, where sulfur dioxide gas is slowly passed through the juice. This gas chemically bleaches the colored compounds in the juice and helps to make the juice lighter in color and cleaner. After that, the clean juice is sent to enormous clarifier tanks. In the clarifier tank, the juice flows at an extremely slow pace, and under the influence of gravity, the heavy impurities slowly settle to the bottom of the tank, while the relatively clean juice rises to the top. The mud-like substance that settles at the bottom of the tank is called mud. An automated scraper mechanism inside the tank slowly rotates and collects the mud at the bottom toward the center and expels it through a separate pipe. This mud then goes to filter presses, where pressure is applied at high pressure to recover the remaining juice trapped inside the mud, and the remaining dry cake is used as organic fertilizer in the fields, which helps to increase soil fertility. The clean juice coming out from the upper layer of the clarifier tank passes through more fine filters, where any remaining tiny particles are also trapped, and a light yellowish clear juice becomes ready to proceed to the next stage. At this point, the clean juice contains approximately 85 to 90% water. And evaporating this enormous amount of water to concentrate the juice is the next most important and energy-intensive step. This work is done through multiple effect evaporators, which are an extremely clever and energy-saving innovation of the modern sugar industry. This large machine generally has 4 to 6 evaporator chambers connected one after another. In the first chamber, high-pressure hot steam is directly supplied from outside, which heats the juice and produces a large amount of water vapor from the juice. The steam produced in the first chamber is not discarded, but is used to supply heat to the second chamber. The steam from the second chamber heats the third chamber, and in this way, multiple chambers can be run simultaneously from a single steam source, and a great amount of energy is saved. In each subsequent chamber, the pressure gradually decreases, and evaporation occurs at lower temperatures, which helps to preserve the color and quality of the sugar. The concentrated juice coming out of the evaporator is called syrup, which contains approximately 65 to 70% dry matter and looks somewhat like thick, sticky honey. This thick syrup is then sent to large vacuum pans, where the most sensitive and important process of sugar crystal formation begins. In the vacuum pan, the air pressure is reduced considerably.
as a result of which the remaining water in the syrup begins to evaporate at just 60 to 70 degrees Celsius. This low temperature is extremely important because at higher temperatures, the sugar can burn or the color can turn yellow or brown, which would completely destroy the quality of the product. When the syrup becomes sufficiently concentrated and reaches a supersaturated state, meaning no more sugar can remain dissolved in the solution, a precise amount of small sugar crystals or seed crystals are added from outside. Around these seed crystals, the sucrose molecules in the syrup begin to arrange themselves in an orderly lattice structure, and gradually, large and uniformly shaped crystals grow. The entire crystallization process is managed by a highly sophisticated automated control system, which monitors the temperature, pressure, and density of the syrup at every moment and adjusts them as needed. After the crystals grow, the mixture formed inside a vacuum pan is called mass cute, where the white sugar crystals and the dark-colored liquid molasses remain mixed together.
High-speed centrifuge machines are used to separate the sugar crystals from the massacute. Inside this machine, a perforated stainless steel basket spins more than 1,000 times per minute. Under the influence of this tremendous centrifugal force, the liquid molasses flies out through the holes in the basket, and the comparatively heavier sugar crystals remain stuck to the inner wall of the basket. After that, hot water or steam is sprayed inside the basket, which washes and cleans off the remaining molasses stuck to the surface of the sugar crystals and makes the sugar even whiter and purer. The centrifuge machines work completely automatically according to a specific cycle, in which the steps of loading, spinning, washing, and unloading continue in sequence. And in a factory, many such centrifuge machines run simultaneously. The molasses coming out of the centrifuge is not discarded. Rather, it is sent back to the vacuum pan and the crystal formation process is completed a second time. In this way, a third attempt is also made, and each time some more sugar can be recovered. The molasses remaining after 3 rounds of processing cannot be further processed economically. This final molasses or treacle is sold as a valuable raw material in various industries, such as for use in animal feed production, ethanol production, yeast production, and amino acid production. The raw sugar coming out of the centrifuge still contains approximately 1 to 3% moisture, and removing this moisture is essential for long-term storage. This work is done through large rotating drum dryers. After sugar enters the drum dryer, warm air flows through the inside and absorbs the moisture stuck to the surface of the sugar grains. Automated moisture sensors continuously measure the moisture level of the sugar, and as soon as it reaches the specified level, the sugar comes out of the dryer and goes to a cooling drum. In the cooling drum, cold air is passed to reduce the temperature of the sugar to normal temperature. Because if packaged while hot, water vapor can collect inside the packet, causing the sugar grains to clump together. In factories where completely white refined sugar is produced, the raw brown sugar is dissolved in water again and a re-refining process begins. This time, the dissolved juice is passed through a large column of activated carbon. Activated carbon is an extremely effective adsorbent material, whose surface has billions of tiny pores, and these pores absorb the colored compounds, odor-producing substances, and other impurities present in the juice. After this process, the juice becomes completely colorless and transparent. Some factories use ion exchange resins, which are even more effective at removing excess mineral salts and remaining colored substances from the juice. Before packaging, the finished sugar goes through rigorous quality control tests. Automated laboratory robots collect samples from the production line at regular intervals and precisely test the purity of the sugar, the size and shape of the crystals, the level of color, the amount of moisture, the amount of ash, and the presence of microorganisms. Modern colorimetric instruments measure the color of the sugar on the ICU-MSA scale, and only sugar that falls within specified standards can proceed to the packaging line. If the sugar of any batch does not pass the quality test, the entire batch is sent back for reprocessing, and this strict quality control system ensures that the sugar in every packet that goes to the market is of high quality and safe. Sugar that passes the quality test enters the automated packaging line. Here, robotic filling machines fill each packet with a precisely measured specific amount of sugar.
Generally, packets of 500 grams, 1 kilogram, 2 kilograms, and 5 kilograms are available in the market. Before and after filling the packets with sugar, high-precision weight sensors measure the weight of each packet. And if any packet receives less or more sugar than the specified weight, that packet is automatically removed from the line. After filling the packet with sugar, the heat sealing machine closes the mouth of the packet in an extremely reliable, airtight, and moisture-proof manner, which keeps the sugar protected from the external environment. After that, high-speed labeling machines print on each packet the date of production, expiry date, batch number, weight, nutritional information, and barcode. An automated vision system automatically checks the label on each packet to ensure that all information has been printed correctly and clearly. The packets are then automatically arranged into large carton boxes, and a robotic cartoning machine closes and tapes the boxes. The powerful arms of palletizing robots skillfully stack the cartons in a specific pattern on wooden pallets. The stacked pallets go to a stretch wrapping machine, where the entire pallet is wrapped with a strong polyethylene film so that the cartons remain safe during transportation and storage. RFID tags are attached to the finished pallets, and AGV robots place them in specific racks in the automated warehouse. In the warehouse, a warehouse management system completely records the location, production date, and batch number of every pallet. When any distributor or large supermarket places an order for sugar, the warehouse management system automatically instructs to bring out the pallet of sugar that was produced first. This policy is called first in, first out, and it helps to ensure the validity of the product. An AGV robot takes that pallet down from the warehouse and delivers it to the loading dock, and it is loaded onto large trucks through an automated conveyor system. Through the distribution network, the sugar first goes to large regional warehouses, and from there, in small delivery trucks, it reaches local shops, supermarkets, and markets. In the case of sugar ordered online, the delivery management system determines the most effective route, and the delivery person delivers the sugar packet directly to the customer's door. After the sugar packet reaches the customer's hands, they check the information on the packet to verify the expiry date and production date. Then they carefully cut the top part of the packet with scissors or a knife and pour the sugar into a clean and dry airtight container for storage, so that the humidity of the air does not cause the sugar grains to clump. While cooking, the required amount of sugar is measured out with a spoon. When sugar is mixed into tea, the heat of the hot water quickly dissolves the sugar grains, and they mix completely with the water, creating a sweet, soothing drink. When sugar is added while cooking payesh or halwa, combined with the heat, it creates a special sweet aroma and an attractive flavor. At higher temperatures, sugar caramelizes, meaning the sugar molecules break down and form new compounds, creating a deep brown color and a complex sweet flavor, which is particularly useful in making various sweets and desserts. After cooking is done, all the family members together enjoy that delicious food with joy and satisfaction. And in this way, the beautiful conclusion of this long, laborious, and scientifically sound journey that began with sugarcane cut from the field comes to an end with a smile of contentment on every person's face.